Have you ever stopped to wonder how your computer actually makes a decision? How it knows to pop up login successful or access denied? Well, the secret isn't some kind of digital magic. It's actually a tiny but incredibly powerful concept called a Boolean. So let's dive into how this one simple idea is what makes all of our code intelligent. Here's what we're going to cover. We'll start with the absolute basics, what a Boolean even is. Then we'll look at the tools we use to create them, see how they control a program's path, uncover some of Python's hidden Booleans, and finally put it all together with real-world code before we wrap up. So first things first, what exactly is a Boolean? Honestly, you can just think of it as the simplest possible decision maker you can have in your code. At its very heart, it's how any program makes a choice, boiling down every single complex question into a simple binary answer. And those two answers are always, and only, true or false. That's it. Is the user logged in? True. Is the number bigger than 10? False. Every single complex decision you see in software really just boils down to a series of these simple true or false questions. But here's a really cool secret about Python's Booleans. Under the hood, they're actually a special type of integer. True acts just like the number 1, and false acts just like 0. And that's why you can do weird-looking math with them and get true plus true to equal 2. It's a little quirky, for sure, but it just goes to show how fundamental they really are. So, if Booleans are the answers, how do we ask the questions? Well, for that, we need some special tools called operators. You can think of these as the workhorses that actually generate all of our true and false values. Okay, the first set of tools we've got are the comparison operators, and they do exactly what it sounds like. They compare two values. Is 5 equal to 5? That double equal sign asks the question, and yep, the answer is true. Is 10 greater than 20? No, so Python gives you back false. Every time you use one of these, you get a Boolean. But what if you need to ask a more complicated question? That's where the logical operators come in. The AND operator is the really strict one. It looks at the Booleans on its left and its right, we call those operands, and it will only give you back true if both of them are true. If even one little part is false, the whole thing is false. Now the OR operator, it's a lot more flexible. It only needs one of its sides to be true for the entire expression to become true. So if you ask it true or false, that's totally good enough for OR, and the result is true. And finally, we have NOT. This one is the simplest of them all. It's basically a light switch. It just flips the value. So not true becomes false, and not false becomes true. Super useful for inverting a condition. Okay, so let's see how this all starts to build on itself. Now that we can actually create true and false values, we could use them to give our program a brain. We can control its flow, telling it exactly which path to take based on the Boolean answers it's getting. And this is the most common way we do that, with an if statement. See here, the variable is raining is set to true. So when the if statement checks it, the condition is met, and the program runs the code inside to print, take an umbrella. But if is raining were false, it would completely skip that part and jump right to the else code. The Boolean is literally acting like a traffic cop, directing the flow. All right, this next concept is a genuine Python superpower. It's the idea of truthy and falsy values. It turns out that Python is smart enough to treat lots of other data types as if they were Booleans, especially in places like an if statement. So here's the deal. Python has a really simple rule for this. Anything that's empty or 0 is considered falsy. That means the number 0, an empty string, an empty list, or the special value none. And literally everything else, any number that's not 0, any list or string with something in it, is considered truthy. Let's see that in action right here. We have an if statement that's checking an empty list. Now, since an empty list is a falsy value, that if condition basically becomes false. The program skips the first print statement and jumps straight to the else block, and it correctly tells us the list is empty, all without us ever having to type the word false ourselves. Pretty cool, right? All right, we've covered a lot of theory. Now for the fun part. Let's see how all these pieces, the Booleans, the operators, the control flow, all come together to build some real functional code. First up, user authentication. This is a classic. To log in, the username must be admin, and the password must be 1234. We use that strict and operator to chain two separate checks together. Only if both of those checks come back as true does the user get in. This is the basic logic that powers millions of login systems. Next, data filtering. This compact little line is called a list comprehension. The really important part is at the end, if n%2 equals 0. That percent sign is the modulo operator. It just gives you the remainder of a division. So for every number, this is asking, is the remainder 0 when you divide by 2? If the answer is true, meaning the number is even, it gets to go into the new list. If it's false, it gets left behind. And finally, making our code clean and reusable with functions. We can wrap that exact same Boolean logic into a function called isEven. Now, its only job in life is to take a number and return true or false. This makes our code so much more readable. Instead of writing that logic out every time, we can just ask, is even 4, and get our answer right back. So, we've covered a lot of ground here, all the way from the basic definition of true and false to how they power some really complex logic. Let's just quickly recap the most important points to remember. First, just remember that Booleans are the absolute foundation of decision-making in your code. Second, we create them using those comparison and logical operators to ask questions about our data. Third, don't forget that powerful concept of truthy and falsy values, where empty means false. And finally, all of this comes together to make our program smart, dynamic, and able to react. Ultimately, Booleans are the building blocks of all logic. They give you, the programmer, the power to control exactly what your program does and when it does it. So the real question is, now that you have this power to make decisions, what problems are you going to solve? What are you going to build? Happy coding!